Welcome to another Python video. What I want to talk about today is a little bit outside of the scope what I had in mind or added onto that. Since it's been brought to my attention that this working with the shell, with scripts, and sort of when to use which, etc., is something that could do with a little bit of a further explanation, a refresher maybe. Um, so I want to do this in this video. I didn't prepare any slides for this, mostly for reasons of time, but also because it requires just kind of jumping around a lot in between the script editor and the live shell. So the, if you're working with idle, the biggest confusion is kind of that idle actually provides both. So when you start idle, on a Windows computer, you get a live shell, but then when you, and I can't do this because I'm on a Linux machine, I don't have idle here, but if you then have it open and you go to the File tab in idle and click New File, then you're actually opening a text file in which you can create your script. So it actually has both of these options. For me, what this looks like is I'm just using a basic text editor to write a script. We'll see what that looks like in just a second. First, sort of what we've mostly been doing up until this point is working in the live shell, right? And I like to start Python from the system shell here, but you may also, click on idle and then you're immediately in Python. These three little arrows, three little arrows, are kind of what the convention that tells you you're in Python now, right? So here um, I can type in any command and it gets evaluated immediately. If you're used to working with R, and I know some of you are, this is similar to when you're in RStudio. In the default setting, bottom left, you have a way to execute command immediately, or commands, code immediately, and top left, you have a scripting window where you sort of write your entire script. This is kind of Python. Um, there are environments that allow you to do both, but the way we're learning it from scratch basically is we're in the shell now, and we can ask Python to do things, and it will do things immediately, right? Classic example: 1 + 1 is 2. X. I don't know what x is. It's not defined. A is 2. A times 2 is 4. A to the power of 2, also 4. So the point here is we have little bits of code, and Python immediately spits back the evaluation at us. And for everything we've been doing so far, that's kind of been enough, right? We don't have super complex scripts yet, so we write a couple of lines of code, right? It's not super complex to do something that's a couple of lines in the shell. For word in this is a great example sentence dot split. We have it print out how long the words are. This is a great example sentence. Okay, fair enough. The script, the shell, the live interpreter will allow us to do all of that. And what's good about this is that we immediately get feedback from Python about whether this works or not, right? The bad thing is that as soon as, well, two bad things. As soon as code gets more complex, it's very difficult to keep track. Keep track of the indents. You mess one up, you have to go through, loop through an entire series of codes, etc. Commands. That's the one disadvantage, and the other disadvantage is it doesn't, it gets evaluated, but then your code doesn't live anywhere. So if you want to reproduce it, you have to type it all again. And very commonly, that's kind of the point in programming, that we don't want to do things over and over again. So for that, we switch to writing a script, right? So I can do the same things here. I can do 1 + 1. I can define an A and then have a script. I'm just going to do one of these. Okay. Note how all of this looks like plain text. And now this is going to be different in idle because idle knows you're writing a Python script. Just going to save this somewhere here. Just call it script.py. So now I tell my text editor it's a .py file, and this is what it turns to. As soon as my computer, my text editor knows it's looking at a Python file, there's a bit of Python logic color coded here, right? For in print, those are predefined commands in Python. Then it recognizes anything within quote marks is a string object. Len is a function, so it has quite a good grasp of what this looks like, and kind of gives me a little bit of help, which is nice. And also, if I mess up an indent, right, I got this wrong, execute the script, it's going to complain. I don't need to recycle everything, recycle through all the commands. I just sort of add the indent. So let me save this, switch to the shell once again. And now I gotta, in order to execute it, I have to not be in Python. So I'm actually gonna go to the system level command line. I use Control D to exit Python, but you will need to figure out what your operating system does. It seems, especially with Windows, that not even all Windows versions kind of do it the same. So you got to figure that out. But now we're in the system level command line, and then I can do Python. And remember, in some cases, if you have Python 2 and Python 3, you need to type Python 3 here. For me, it's just Python, and then the path to my file. And I call it script.py. Okay, an important difference we see is that, going back to the script, there's a bunch of commands here, right? 1 + 1, a is 2, a to the power of 2. All of this gets evaluated by the script, but it sort of evaporates, right? The script only puts out something that it is explicitly told to not just evaluate, but to print or to do something else with. If it just evaluates, sort of, it does that internally and nothing happens. So actually, with all the commands here, we only get the print command, these printed lengths here, and the stuff. So we're here going back up here, scrolling back up. Sorry, I gotta switch the display. Scrolling back up here to within Python, right? All of this was evaluated in the live script. That's not the case if we're live shell. That's not the case if we're evaluating a script. So there's a difference here. In a script, you sort of have the opportunity to build code from less complex to more complex. And while you're doing that, you'll want to also have the live shell open and try little bits of code out, sort of incrementally complexify your code and see whether the bits you're working on right now, whether they work. But ultimately, you want something that looks like this, although maybe a bit more complex. Let's look at a more kind of complex example. Just a second. Use the Trump mentions file. Oh, doesn't exist anymore. I moved that. That's a shame. I guess model solution for homework 1 isn't a terrible thing. So now, right, going through all of this, we can kind of see several advantages of having this in a script. The first is it's a lot of code, and we can, keep track of it. And the second is we actually can produce the code and then also include, comments, little markup that tells us what the code does, why we chose to do it in a certain way, etc., etc. In this homework script, I mean, this is mostly my comments and prompts for completing the homework. But when you're actually writing a script, you will want to write notes to yourself about what happens in a certain part of the code, so you don't have to sort of read through all of it carefully to understand what it's doing. And the way this works, I think we sort of addressed it but never really focused on it. A hash tag, like this number sign, anywhere in the code basically means everything following that up to the next line break does not get evaluated as code. So most of this, you can do, I prefer to do it separated, right? So we have lines that are only comments and lines that are only code. But technically, you could also write something like this. This line splits my text into a word list. That's also possible. Sometimes when you import things or when you have a very short command and just quickly want to write about what it does, that may be more sensible. So this is script and shell and the relationship between the two. At the beginning, at the stage where we're at, it's maybe a bit difficult to see, what the big difference is, simply because our code is not very complex yet. But you can maybe think of it kind of like you're writing a term paper, and maybe you're the type of person who scribbles down notes somewhere, maybe even just underlines or highlights text in other documents. All of that is sort of kind of akin to what you're doing in the shell. But then when you actually produce the structured outcome, the thing you want to have as a final product, you're going to want to have that as a script in Python. So I hope maybe that makes it more clear. For those of you working in idle, just be aware that idle includes a shell and the possibility to create a text file with a script as well. And when in doubt, Python. These guys, sorry, I forgot to switch the display. These guys, these little three little arrows here, they're the indicator that you're in Python, in a live shell, that Python is ready to immediately interpret your commands. So that's really that. And then there was a second question about where do you go to sort of, if you have a problem, how do you address that? I want to quickly go to the main page for the course. There's this little tab here, getting stuck, and it has four different kind of problem solving strategies. The ask yourself strategy just kind of sort of mentions a couple of common errors that in my experience you tend to make when you're a beginning coder. And then ask Python is basically accessing the help function. We'll look at that in a second. Ask others. There's a forum where you can post your questions. It doesn't seem to be in high demand yet, which is fine, I guess. I mean, we're meeting and discussing these things, but that possibility is there, and I cannot emphasize enough how amazing the internet is in this regard, right? You go to Stack Overflow, type in sort of what you want to do. Oh, yes, I'm a human being. All right. And chances are there's going to be discussion around, what you want to do. And very often, especially with this Python stuff, people don't just present one solution, but give you like 4 different approaches that will also kind of help you see, um, what different approaches to coding there might be, and maybe sort of help you learn something about Python beyond addressing just strictly the problem. So this is a great place to go. There is also within Python the help function. So let's look at that just really quickly. So we're in Python. Help str.strip, right? This is not very, sorry about that, not very verbose, but it basically describes what the function does, right? Return a copy of the string with leading and trailing white space removed. Strip. If chars is given, so this is the default behavior, no character specified. If characters is specified and not none, remove characters in chars instead. So this means basically anything that's in there, if it's to the left or the right of the string, it gets removed, right? It's just kind of an example to show you how you can access the help function. In the case of Python, honestly, this is kind of different for R, for example, where I think you get quite a lot out of the internal help function. Personally, I would say with Python, like my first go-to is actually always the internet, and then specifically Stack Overflow. So finding help there, that also gets easier the more you know about Python, right? Just knowing how to ask a question can help immensely. So this is also a learning process, but this is my best advice, is to just utilize the hive mind of Stack Overflow. So this is just a refresher on kind of how we're working with these different environments. And then shortly there'll be 2 videos upcoming on how to get rid of this stupid copy paste one big string into my shell or my script, and actually sort of read something from a file and writing something to a file. So I think that should be exciting. Will mark a major step forward in writing useful programs, and I'll see you for that. Take care.